In this chapter, we're going to explore the critical first step in web application security, figuring out exactly what you're up against by gathering information. This process is called application mapping, and it's kind of like drawing the map of an unknown land before you even think about exploring it. Honestly, it's a foundational skill that really separates a methodical, professional attacker from someone who's just, well, guessing. So, this really brings us to the central question for this whole thing. It's simple, right? You can't attack what you don't understand. I want you to think of yourself as an explorer, charting a brand new digital territory. Before you can find any hidden treasures, or in our case, security weaknesses, you first need a detailed, accurate map. This isn't just some preliminary step, it's the very foundation of the entire attack. So how in the world do we create this map when we're basically starting with a blank page? At its core, application mapping is all about building a comprehensive catalog. We are systematically listing out absolutely everything the application contains and everything it can possibly do. The goal here is to identify what we call the attack surface, which is just a fancy way of saying all the different points where we could potentially poke and prod for vulnerabilities. Okay, let's dive in. Our journey is broken down into 4 key stages. First, we'll survey the known world, just enumerating all the content you can see right off the bat. Then, we'll venture into some uncharted territory to find hidden files and functions. After that, we'll learn to decipher the clues on our map by analyzing the application's technology. And finally, we'll put it all together into the ultimate treasure map, a complete diagram of the attack surface. So let's start by mapping the coastlines. This first phase is all about identifying the content and the functionality that the application openly presents to us. We'll begin by just browsing the application and following every single link that we can see. Now, we could just browse the site manually, clicking every link we see, but that would be super slow and we'd probably miss things. To be more thorough, we often start with an automated tool called a web spider. A spider works a lot like a search engine bot. It starts at a URL you give it, requests the page, and then it parses the HTML for every single link it can find. It then adds those new links to its to-do list and follows them one by one, repeating this process over and over until it's explored every path and can't find any new pages to visit. All right, let's look at a real example. This slide shows an automated tool called Burp Spider that's mapping an application. Over on the left, you can see the sitemap it's building. It's this nice tree structure of all the directories and files it has discovered. But what's really interesting is what it found when it requested a special file called robots.txt. If you look at the response on the right, this file, which is supposed to tell friendly search engines which directories to ignore, has just handed us a list of potentially juicy locations. It's pointing to MDSec portal and site-old. These could be admin areas or places with old vulnerable code, and importantly, they weren't linked from anywhere else on the site. But relying just on an automated spider has some pretty major drawbacks. These tools are fast, yeah, but they aren't very smart. They can't figure out complex JavaScript menus, they fail on forms that need specific input, and they often break your session by accidentally clicking the logout link. And worst of all, they can actually be dangerous. An automated spider can't tell the difference between a view profile link and a delete user link, and it will blindly click both. Not good. So clearly, we need a better approach. This brings us to something called user-directed spidering. The idea here is to combine human intelligence with automated power. We use a tool called an intercepting proxy, which is basically software that sits between our web browser and the internet, letting us see and even modify all the traffic. We just browse the application like a normal user, logging in, filling out forms, exploring features, and the proxy just passively watches in the background, automatically adding everything we visit to the sitemap. This way, we really get the best of both worlds, the intuition of a human who can navigate complex logic, and the thoroughness of a tool that logs every single request. And this slide right here, it illustrates the difference perfectly. Remember, the automated spider was totally stuck at the login page. But here, you can see the sitemap after a human user has logged in. The proxy has now mapped out the entire /home directory, which was completely inaccessible before. It's discovered pages for my account, partner, and search. All of these are critical pieces of functionality that were completely invisible to the automated tool. This is exactly why user-directed mapping is so essential for creating a truly complete and accurate map of any modern web app. Okay, so we've mapped the visible world. Now it's time to find what's hidden. Applications often have content that isn't linked to from the main site, things like old backup files, pages for administrators, or maybe functionality that's still in development. Finding these hidden gems is key to uncovering the full attack surface. One of the most effective techniques for finding this hidden content is called brute forcing. The logic is actually pretty simple. We start with the directory we already know about, like /auth. Then, we take a long list of common file and directory names, what we call a word list, that has things like admin, config, backup, test, and so on. Our tool then just systematically requests each one, /auth/admin, /auth/config, /auth/backup. By watching how the server responds to each request, does it give us a page not found error or something else, we can figure out which of these hidden resources actually exist. And here's what that looks like in practice. We're using a tool called Burp Intruder. We've set up a basic request to the application's root directory, and you can see we've marked a position right after the /. Now, the tool is going to take our word list of common directory names and just insert each one into that spot, sending a brand new request for every single word. Okay, now let's look at the results. This table shows the outcome of our brute force attack on that /auth directory. Each row is a different file name we tried. And if you look at the status and length columns, you can see how the server responded differently to certain requests. Most of them came back with a 404 not found, but a few, like register and profile, returned a 200 OK, which means they exist. The most interesting discovery here is that register page. Our initial mapping only found the login function. Discovering a registration function opens up a whole new area of the application for us to investigate. Now, it's really important to understand that we are not just looking for a 200 OK response, which means success. Other HTTP status codes are also super valuable clues. For example, a 302 found that redirects us to a login page that strongly implies the resource exists, but we need to be authenticated. A 403 forbidden is even better. It's explicitly telling us the resource is there. We're just not allowed to see it. Even a 500 server error can be a good sign, suggesting the page exists, but it just crashed because maybe our request was a little weird. All of these different responses help us fill in the hidden parts of our map. And beyond just brute forcing, we can use other clever techniques. We can use inference. Like, if we see a file named viewuser.jsp, it's a pretty good bet that edituser.jsp or maybe adduser.jsp also exists. We can also use public info from search engines and web archives to find pages that used to be linked but aren't anymore. And finally, we can check for default files and directories that just come with common software. Okay, so now we have a map with lots of locations on it, but a map is pretty useless if you can't read it, right? This next phase is all about analyzing what we found to understand the application's inner workings, its functionality, its security mechanisms, and the technologies it's actually built on. One of the most important things we have to do during this analysis is identify every single place where the application accepts user input, because each one is a potential entry point for an attack. You've got the obvious ones, like parameters in the URL query string and data submitted from web forms, but we have to look deeper. We need to examine the URL paths themselves, the values stored in HTTP cookies, and even other HTTP headers like the user agent or referrer strings. Basically, any piece of data that comes from the user and is processed by the application on the server is part of our attack surface. We also need to identify the server-side technology. And this slide shows a perfect example of a simple but really powerful fingerprinting technique. Let's say we think a server is using Microsoft's ASP.NET framework. We can test this by requesting a file that doesn't exist, but ends with an ASPX extension. If ASP.NET is installed, the framework itself will handle the error, and it gives back this very specific detailed error page you see on the left. If it's not installed, a different part of the web server will handle the error and return a more generic page like the one on the right. This simple little test tells us a huge amount about the technology stack we're up against. And there are so many other clues we can look for. File extensions are a huge giveaway. .jsp points to Java, while .php points to PHP. Certain directory names, like /servlets, are also really strong indicators. And even the names of the session cookies, like JS Session ID for Java or PHP SSID for PHP, can tell us exactly what platform the application is running on. Well, we've reached the final stage of our expedition. It's time to take everything we've discovered, all the visible content, all the hidden pages, and our analysis of the technology, and combine it all into our treasure map. This map is going to clearly lay out the application's full attack surface. And this is where all of our mapping work really pays off. The power of having this completed map is that it lets us move from just looking around to doing targeted testing. We can now connect specific types of functionality to specific classes of vulnerabilities. For instance, when our map shows a feature that talks to a database, we immediately think of testing for SQL injection. If we find a file upload form, we're going to test for path traversal vulnerabilities. Any page that displays data submitted by a user is a prime candidate for cross-site scripting. A login mechanism is a target for brute force attacks. Our map becomes a strategic guide, telling us exactly where to look for specific kinds of weaknesses.
And here it is. This is the culmination of all our work, a complete sitemap for our example application. It shows everything we found, from the visible shopping cart functionality to the hidden registration page we brute forced and the unlinked site stats page. Each of these branches represents a different part of the attack surface and a different avenue for us to explore in the next phase of our security assessment.
So, what's the most important takeaway from all of this? It's that a thorough, patient, and methodical mapping process is not a waste of time. It is the most critical investment you can make. This foundational understanding is what enables a truly effective security test. Skipping this step is like sailing into uncharted waters without a map. You're probably going to get lost, and you're definitely going to miss everything important. And that brings us to our final thought. We now have our completed treasure map. It's filled with potential targets. The login page, that newly discovered registration function, the file upload feature, the user profile pages. The entire digital frontier of this application is laid out right in front of you. The only question left is, where would you begin?